Hey guys, in this video we will see about a static keyword. So what is a static keyword? So just like we have const keyword, similarly static is a keyword which we can use to make a variable or a function to behave in a certain way. So let's see point by point what are all the properties of a static keyword. So first thing, memory allocation for a static keyword is done only once. So it do not get reinitialized in the new scope whenever you are calling it again or with some function or something. So whenever it goes to the new scope, it will preserve the value of the previous scope. So let's see with an example. Suppose I am creating a function here and I am creating a static variable int a, initializing some value and then incrementing it. Now at the end I am printing the value. What will happen with the normal variable? If I use a normal variable, so it will be initialized to 10, it will be incremented and then it will be printed. So if I will call it multiple times, only 11 will be printed, 10, 11 here, and then it will be printed. So let's check it. I am calling fun for the first time and the second time and the third time, and every time 11 should be printed. So let's see. Now you can see here every time 11 is being printed. Now let's change it to a static variable. Now let's compile again and run. Now you can see 11, 12 and then 13. So this statement here at line number 5 is being called only once. So you do not get memory allocation for different times. So it is being called only once. Alright. Now let's move to the next point. A static variable in a class is shared by all objects. It do not create multiple copies of a static variable for multiple objects. So if your class having some static variable, then whenever you are creating some objects multiple times, you are creating a number of objects, so that particular static variable will get memory location only once, and that memory location will be shared with all those objects. So let's see with an example. Suppose here I am creating a entity class where I have declared a static variable. In the constructor I am incrementing the count of this static variable. I have a function to return the count. So we need to initialize static variable explicitly outside the class. So we can initialize like giving the class name and then a scope resolution operator and then count equal to 0. By default it will be initialized to 0, but we can initialize to some other value. If we want to initialize to some other value also, then we can do like this way. Now suppose I am creating before that we do not need object to access static variables, so we can access through the class name and the scope resolution also. So let's see. I have not created any object yet. I am using it through the class name only. Let's compile it. So now you can see it is able to access the variable. So now next thing, let's create some objects here. I have created two objects here. This static variable is already initialized to 0. So when this will be called, constructor of this variable will be called and then it will be incremented by 1. And when this again it will be called, then constructor will again be called and then it will also be incremented by 1. So let's print the value of this count. Now you can see count is being printed to 2. So for the first time count was 1. Let's print the count here as well. Let's run it again. So for the first time when this object A is created, count became 1, and when the next time, since it is using the same memory location, so the value 1 will not get destroyed, and so this will again be incrementing in the same memory location, and then it will become 2. So let's see with the diagram how it is happening. Suppose you have a class which is containing a static variable and some normal variable and bunch of functions. Now even if you are not creating the object of the class, the memory for this static variable got allocated, and it will be by default initialized to 0. Now suppose you are creating an object obj1, rest of the normal variables will be copied every time, but the static variable reference for the static variable will be pointing to here at this common location. Suppose you are creating another object, rest of the normal variables will again be copied, and this static variable will be pointing to this common location. So in our example it happens like we created this object obj1, the value got incremented to 1 here. Now you again created the object obj2, the value again got incremented to 2, so the count became 2. Alright, the scope of a static variable is limited to the current file only, means current CPP file only. So if you are creating another CPP file, suppose I am creating a test.cpp, I am declaring a static variable here, so this variable will be accessible to this file only. You cannot access this variable in other file. In case of normal variable, it can be accessed throughout the file. So let's see with the normal variable a in test.cpp, or normal variable, and I want to access this into the main.cpp. So I can access it. I need to tell the compiler that you need to check for this variable in other translation unit. So I can declare it as like extern int a, just a declaration only. Go ahead and compile. You have to compile both the files. You can see 7 got printed here. So you are able to access this in this file. Now if I will make this static, then this variable will not be accessible to the other CPP files. Let's go ahead and compile again. You can see the linker error here. The linker is not able to link like where to look for this variable, even if I have declared it as extern, because like this static have limited scope to this current CPP file only. Same thing with the static function as well. Suppose you have a static function here. Let's get rid of this first. Suppose I am declaring a normal function here. I am printing hello only. I have a function here. Now I want to, since I need to include a string here, now I have a function here. I want to use this function in some other CPP file. So let's call this function. We also need to declare this function, not with the extern, unlike a static variable. Just you need to declare it, and the linker will link to the correct location. Let's compile and run. See, it is able to print this from that file. So I am calling this function in main.cpp, and the definition for that function is present in test.cpp, and I am able to access this. Alright. Now if I will declare this function as a static, so it will limit the scope of this function to this file only. It won't be accessible in main.cpp. Let's compile it again. Now you can see the linker here. Alright.